We now move on to our session on battery and motors, and we have 4 panelists. I will introduce them in order of appearance, and then I will introduce the first speaker for the day. Our first presenter is Mr. Babu KSV, Business Head E-Mobility, Automotive Motors and Cooling Solutions, Lucas-TVS. He will be followed by a joint presentation by Mr. Wicher Kist, CEO, Saietta Electric Drive, and Mr. Kabir Bhandari, MD, Padmini VNA. This will be followed by a presentation by Michelle Marks, Business Development Manager, PM eDrive. And finally, we will end with a presentation by Girish Kamala, Senior Director and Country Head Sales, Automotive at Infineon Technologies. So looking forward to another exciting and very, very knowledge-filled session. And I would like to call on Mr. Babu KSV, Business Head E-Mobility, Automotive Motors and Cooling Solutions at Lucas-TVS, to start this presentation. We've got 15 minutes, and we look forward to an interesting session. Over to you.
Thank you, Atul. Good afternoon, colleagues. Okay. Good afternoon once again. Before I talk about our products, let me give a very brief overview of our company, Lucas-TVS. It is a South Indian headquartered company with heritage of 50 years in manufacturing rotating electrical equipments. And we make about 15 million machines a year for wide range of applications ranging from two-wheeler to the tractor and the earth-moving equipment. And we are part of TVS conglomeration, but run independently. And the other interesting point is, even though this is a very old company, is now certified as a great place to work successfully for 2 years. And this year, we have been identified as a great place to work in the auto component space. We have also increased our focus on R&D, primarily to increase the local design, development, and validation of wide range of products in the automotive segment as well as consumer goods segment. And now on the electric mobility, we started investing approximately 4.5 years back and developed a wide range of products for two-wheeler, three-wheelers, small commercial vehicles. Besides this powertrain products, we are also entering into the battery cell manufacturing with a gigafactory in the northern suburb of Chennai with a unique and disruptive technology. Primarily, this offers an excellent energy density with the capex, which is 30 to 40% lower because of this technology. More details will be shared in the press in the coming weeks. Now let me come to the powertrain, what is the topic of the day. Before I start about our product development, most important is what is expected from the consumer and what are their key concern areas. So in an electric two-wheeler, first concern or the expectation of a buyer is the range or mileage. So how does it matter to us as powertrain or battery manufacturer? So the mileage depends on size of the pack and efficiency of its drive components, motor, controller, transmission parts. Then comes the weight of the products, which can be managed through lightweighting and recovering some of the energy from braking action or from the gradient where it is freewheeling is possible. The second concern is the high initial price. In the last 1.5 hour discussion from the OEM teams, you heard clearly the vehicle price has been a dampener as far as business is concerned, or faster growth. Therefore, subsidies from the center as well as state and certain concession are helping. And this is also putting pressure on the products of powertrain and batteries to be economical. To compete with ICE vehicles, it is important these components also become affordable. The other concern is what kind of recharging we can do, whether it is in the home. In a two-wheeler private owned, it is much easier. We can do the slow charging at home in the night. Whereas in case of fleet taxis, even the bike taxi, what has been authorized now in Karnataka, they need a solution of fast charging, at least a medium charging, so that they can increase the SOC level from 20, 30 to 50% or so in half an hour or 45 minutes. Other possible solution could be swapping, but it comes with its own pluses and minuses. And the other point also spoken in the morning was battery pack replacement cost and serviceability. These are the inputs what has gone into the design of our powertrain and also in future in the battery cell. Now come to the key members, power source and the powertrain. In an electric vehicle, there has to be a good marriage between these two components. That is the motor controller and the power source, that is the battery pack. Why? The range depends on the size of the pack. It is nice to have a very big pack, but when the cost becomes not affordable, if the pack of the pack size is very small, the continuous power output as well as the performance is significantly curtailed. So the range and the performance both depend on how we select both the items together. Similarly, the gradability. Everyone would like to have 15-degree grading or 20-degree gradability for their vehicle when they conceptualize, but it is not only the motor which can meet the peak torque, but the C rating of the battery. If the battery has a poor C rating of 1 or 1.5 C, then it can deliver only a certain amount of peak current, which curtails the output of the motor and the controller. So in a nutshell, similarly, pack life depends on how many times we discharge, and also regeneration is nothing but charging of the battery pack, also takes away a certain amount of life, and communication. So this is to demonstrate you cannot independently decide a motor or a controller or a battery pack. A proper marriage is essential. Now coming to the powertrain in a two-wheeler, where do we fit our motor and controller? The most common and the simplest solution is to have the motor in the wheel, in-wheel motor or a hub motor. From the vehicle design point of view, this is the easiest, but it has a issue of unsupported spring mass or have certain limitations in terms of the design, and the size of the wheel also determines the maximum power output what we can develop from this wheel. So the alternate ideas are a frame mounted where the motor is below the seat and the controller is somewhere around that. The power transfer happens through a chain or belt depending on the design. Third is a swing arm mounted, wherein the motor is provided on the swing arm, power transfer through a small gear train. And the other commonly used topology is having the motor near the footrest and transferring the motion through a chain or belt. This is just like our IC engine is scrapped, and at that place we are placing the motor. Controller could be at the front place or any other place suitably located. So Lucas-TVS has identified and understood the needs of the vehicle designers. Each vehicle designer would like to achieve certain specific attributes to their vehicle. Powertrain is not going to decide the vehicle attribute, but it is only a subset. Therefore, we work with all types of design expectations of the vehicle makers and provide solutions to each of their requirements. Coming to the simplest one, which I explained, the hub motor. Here, depending on the type of wheel design, it could be 10-inch wheel, 12-inch wheel, 16 or 17-inch in case of a motorcycle. And power outputs can be anything. The continuous power could be up to 3 kilowatt. It started with some 250 watt, 0.25 kilowatt from the Chinese makes. Most of these vehicles are now out of action. Most of them use anything between 800 watt to 1.5, 2 or 3 kilowatt. Then they can also use a brake drum type of arrangement or a disc type arrangement. The only drawback, what I would say in this system is, apart from the power output, depends on the size of the wheel rim. There are these, while designing, we have designed IP67 with a nice gaskets, everything. When it goes to the repair, and if they do not replace the parts properly, there is a chance of water ingress. And this may be one point when we consider the serviceability in the field has to be kept in mind, because this part is in the water level most of the time when we travel in the monsoon season. Therefore, original design may be IP67 from the Indian manufacturers, but if it is repaired and improperly handled, you do have issues. The second concept, which I explained, the second and fourth, uses a motor. Typically, we are strong believers of a PMSM motor, which helps in a constant power, constant torque regions, and have the very high efficiency. A combined motor controller efficiency of 94% is achievable. And we have also demonstrated at some of our esteemed OEMs. These can be designed depending on the customer needs, either for 48 volt or 72 volt. Both are going to series production for a few customers of ours. And the FOC control helps in having very high operating range for the motor without a gearbox. For example, if you look at operating a scooter or a motorcycle up to 90 kmph, the same motor can work from 100 RPM or 500 RPM equivalent of idling to 9,000 RPM or 7,000 RPM as the customer needs. For very high performance bikes, which look for 10 kilowatt or 12 kilowatt, 15 kilowatt kind of power outputs, just to make it clear, 12 kilowatt means something like 16 or 18 horsepower of an IC engine. So we also have solutions. And in the lowest end of the spectrum, which is also useful from the e-commerce vehicles, like small item delivery vehicles, we do have hub motors, which are based on 36 volt system. I explained about the motors a while ago. Equally important is the controller. Controller is the one which draws the power from the battery pack and decides and supplies how much current for what kind of duration it has to be given. And it is the most intelligent part in the vehicle. It can also convey the information to the dashboard on wide range of aspects, including the battery information, motor information, and controller's own information. And this is one of the third highest in the value in the electric two-wheeler. If I can put the value-wise, battery pack is the first, motor and controller occupy second and third in whatever way you look at it. So these controllers are equipped with wide range of features, and any electronic device, as most of you understand, adding another feature will only give very small increase in the cost, unlike a mechanical item. So as customers expect more and more comfort and safety features, we can add them with minimal impact. So some of the features shown here are voltage protection, it could be high voltage or low voltage, similarly current protection. And the most important and concern item is the temperature protection in case of electric motors, because the PMSM motors have permanent magnets which can become demagnetized under very high temperatures, and therefore as the temperature exceeds certain value, it could be done as a derating, or it could be taken care of as a cutoff or limp home, depending on whatever is the strategy OEM wants to apply. And as most of the vehicles also come with multiple drive maps, it could be called as sporty, eco, safe, or mountain and or hilly ride and so on. These can be very easy to fine tune and structure based on the OEM's requirement. From the financier's perspective, immobilizer function, if somebody do not pay the money or the installment, either the battery could be made as immobile or the motor or the controller through a software key and through remote means, also through a telematic device. So immobilizer function is another key point, and telematics and communication to the dashboard are some of the key features of the controllers. There is also another concept. When we spoke about a motor and controller as two separate devices, it offers certain flexibility in terms of fitment and also temperature management. Whereas from the cost perspective, it is ideal to have the motor and controller integrated together. So we are working with a couple of interested parties in the Europe and elsewhere, wherein the controller is integrated in the motor, and this offers extremely a high advantage in terms of complexity reduction. So no loose wires and all wiring harness eliminated to a large extent. Efficiency is improved and also compact, and the cost of these external wires, routing and shielding, all these are eliminated, resulting in a better cost. But it also comes with quite complex thermal management aspects and reliability, and the components in the soft electronics need to be suitably designed to manage little higher temperatures. So it is up to the OEM to decide what is their strategy, and we as a component supplier are ready to work with them to offer ideal solution to their requirement. In the beginning, I also spoke about the cost of the motor, and the four key drivers in the cost of a permanent magnet synchronous motor are rare earth magnets. The cost of this could be as high as 30 to 35% of the motor, because it is currently dominated by Chinese and maybe Korean, Australian, and few other players are there, Japanese, but China is the dominant player, and India has almost no local content available. Then we need lamination steels, which are extremely expensive as you go for thinner and low wattage loss material. All look like alike when you look at the steel, but the difference comes in the selection of the material, wherein energy loss content is lower. The cost could be as high as 2 times the normal steel. Then double enameled copper, its temperature resistance and encoder and its accuracies determine the cost driver. So a typical motor may be possible to get. This is where most of the people get confused with the Chinese stuff is cheaper. Cheaper in terms of what and why is the key aspect people from the technical fraternity need to analyze and understand. We have decided to invest in different production lines, a BLDC motor, a line, hub motor line, and a PMSM motor line. BLDC motor line is already in operation since 2 years. Hub motor and PMSM motor line will be operational in this quarter. Already all the machines are ready and run at rate trials are going on. Controller assembly lines are also under operation. And some other lines are coming into picture. So we would like to assure the OEM fraternity of two-wheeler, three-wheeler, and the small commercial vehicle. We are ready to offer you products what you want at price points which are compelling and technology of world class. I also want to touch upon thermal management is another aspect apart from the powertrain what I spoke. This is also necessary both for the powertrain as well as for battery cooling. So we do provide solutions for cooling of motors, controllers, battery packs. So to sum up, I would say Lucas-TVS has in-depth capability and knowledge. We can offer right product and right solutions. We offer a shorter development time and a faster response. Basically, we have inculcated a separate culture of startup in this world company of 60 years, and we are a startup in the large company. And we do have an extensive testing facility. We can support even the startups to do their testing. And that's it from my side. Thank you for your attention. And if any questions are there, I can answer now or at a point of time. Back to you, Atul.
Thank you, Mr. Babu. And I can say anybody who missed this session will be banging their head on the wall, but luckily you can watch this later. A really, very concentrated, high quality presentation with a lot of information and detail that I'm sure will be very interesting for all who are, watching the program today. So thank you, Mr. Babu, once again, and also for being very time conscious with your presentation. And I look forward to coming back to you with questions a little later today. We now move on to our second presentation. It's a joint presentation by Mr. Wicher, Kist, CEO, Saietta Electric Drive, and Mr. Kabir, Bhandari, MD, Padmini VNA, a joint presentation, also about 15 minutes in length. And I can't wait to see what we will learn from the second presentation for today. So over to you, gentlemen.
Good afternoon. Good day. Greetings from Europe and Kabir in India.
Yeah.
Just a quick question: are you sharing the presentation, or are we sharing the presentation?
You're sharing it, Vic. That's what Brad told me.
Excellent. Let me get that ready.
We truly have intercontinental collaboration.
That we do.
Let's see if this works.
That's what Brad told me.
Yes. There
Can you see the? Is it in presentation mode now?
Yes.
Excellent. So yeah, thank you all for allowing Saietta to present. I'll kickstart. My name is Vic, CEO of Saietta, calling in from Europe, and I'm delighted to tell you about our technology breakthrough and how we can add value to India, especially with a UK motor that will be made in India. Try and get. So as an introduction, I'll race through it really quickly, but basically we are an established engineering company. I'm also very pleased to say that we just listed the company at the London Stock Exchange last week, and we focus mainly on axial flux motor because effectively it gets you further on the same battery. It's all owned by Saietta, but will be developed further and manufactured by Padmini in India. And it is totally modular. You can make it bigger, you can make it smaller. The design is extremely efficient and delivers high torque, high power, and high efficiency. And it is specifically designed for that 110cc motorbike segment, but we can go much bigger and much more powerful. We've designed it ourselves, so therefore, and we know the Indian market very well, we focus purely on low cost, compact, lightweight, and extremely durable design solutions. And we are now ready to take on the first substantial programs with Saietta VNA, which will be the joint venture between Padmini and Saietta. And if you are interested, you can also find us on the green economy under SED on the London Stock Exchange. The way we tend to work is that vehicle manufacturers want to go to production as quickly as possible. We can integrate it into your vehicle, we can prototype it, we can test it in-house, India or in the UK, and bring you to production pretty much faster than the very large tier 1 suppliers. So we welcome your inquiries on that. Here are a few examples. There's a Hero 160, which we converted to a 5 kilowatt swappable battery with the Saietta technology. The swappable battery is purely a demonstrator, but think Gogoro, where you can also fit the batteries from the top. The scooter is for a Thailand company where we integrated it into the swing arm, and basically with an integrated inverter, bringing costs down even further and sharing the coolant system. Over to you, Kabir.
Thanks, Vic. So, hi everyone. Thanks for giving us this opportunity to present. Just a short thing about Padmini. Padmini has been around for about 20 years, and we've focused always on powertrain solutions and reduction of CO2. And now with the move towards electrification, which we believe will happen first in the two-wheeler space, we work extensively with Vic and Saietta, and we're convinced that we've brought the best possible motor technology to India. We've believed always in differentiation of technology, and like Vic said, this is an axial flux motor, so it has a very different topology, and that allows it to be more efficient than radial flux machines, more compact, and therefore offers a higher range for the same battery pack. So let me just go to the next slide. Thanks, Vic. So at Padmini, we've always focused on engineering, focused on the development of IP, and have extensive testing facilities. We have extensive analytic facilities, extensive facilities for basically design and development, and mating that with what Saietta does in Europe, I think gives both of us a real winning partnership, and we're really excited to bring an excellent machine to India. Go ahead, Vic, all yours.
Great. So how the focus here is, here you see two motors. So it's the AFT 110 and the AFT 140. The AFT 110 has adequate performance to give you like the 110cc performance feel. You don't need a transmission anymore. You can pretty much run the sprocket directly off the shaft. We can also, of course, together with Padmini, integrate it into your suspension arm, and then you can delete even more components and make the belt drive in a clean space. Again, durability, reliability, and basically the highest efficiency possible. And we're already talking to the large vehicle manufacturers in India. The AFT 140 you can do a lot with. You can look at our YouTube channel and it will give you a good impression of what we're already doing in Europe. As a quick reminder of the USPs, it's one of the highest torque density motors on the planet. Pancake shape, fit and forget, fully sealed IP67. We have focused on low voltage. So this motor works at 48 volt. It works at 60 volt. You can also make it run directly on solar panels for example, water pumps. It's low speed, therefore the reduction gears are not required, and extremely durable, and the heat rejection, and that's where we are truly unique, and we've got that patented. It's a water-cooled motor because we know that making millions of these motors work in Mumbai, in Chennai, and in the middle of Delhi, you need water cooling. We're now working on a program to integrate the inverter and sharing that cooling system, and all of that is designed to make it fully automated and with the cheapest components available. Therefore, we believe it's the right performance at the right price for the target mass market. The market we're focusing on, it's, I mean, we are truly motivated by helping Asia clean up the air in large cities. And as we've seen in 2020, there is a blue sky in Delhi, and we want to keep that way. So we are here to help. From a market positioning point of view, we are fully aware that in China it's very much mopeds. That's not really for our motor topology. We don't really believe in heavy motorbikes because then you need bigger batteries, and that's why we developed the AFT 110 and the AFT 140 for that 100 to 165 market segment, CC market segment, which is around 72% of the market in India. We understand the requirements very well, so we have, from a duty cycle point of view, we know what torque we have to deliver. We have several bikes up and running, and we've had them up and running for quite a while in the UK, and we are now shipping the first demo bikes to Delhi. So please contact Saietta VNA, Padmini, Kabir, and get your appointment set up for late summer. This solution works. We've tested it, we can prove it to you. And we do that by deleting the entire powertrain. We can run the motor directly on the chain. Because of the high torque, we can meet all of the duty cycle requirements in the city. Because of the water cooling, we can make the vehicle drive further than most on the same battery. It's on low voltage, so therefore it's safe to work on, and it is extremely competitively priced. To wrap that up, had the advantages of water cooling. It allows you to achieve that high torque, because if you're in the city and you're pulling away from the traffic light, it's stop, start, stop, start. I have spent hours in the back of taxis in most of the cities in India, and there is no speed. You can't pick up any speed. We've seen so many vehicles being launched into the market, and within weeks they have overheating problems. We've learned from that already 4 years ago, and therefore with the other components that Padmini supply, we know that water cooling in this 110cc market segment will be the dominator in the future.
May I just butt in for a second, Vic?
Sure, please. So
basically, when we looked at the Indian market, key is what Vic showed on the previous slide. You see 4 and 5 people sitting, a whole family sitting on two-wheelers. And that's a reality in India. So you need the high torque right at the bottom when you're starting up. You need that high torque to be able to go over the hilly bits and pieces that we have, flyovers. If you sell a bike in the hills, put 4 people on it, and what happens to your EV? So our motor is designed to handle that. And as Vic said, when we looked at the water cooling, the key there was to offer that option to customers. So we've got it in our architecture. We can also give you air cooling. That's possible, but with water cooling, you just have this incredible thermal performance, which avoids totally any derating of the motor, allows us also to put in high current for regeneration, which helps the battery. And all in all, the motor is completely sealed. You can put it in underwater, you can do what you like with it, and it really works. And that was the goal. The goal was to make a motor that takes all the abuse, all the conditions that India throws at you, which no other country does.
Great, thank you, Kabir. So let's talk about how to implement this. And this is where I get really excited. And you have a scooter and it's electric, and you then get home and you can't carry your scooter to the apartment to charge it. You can't throw an extension lead out of the balcony either. So the only way to do this is to work with swappable batteries. And this is fundamentally why we believe this is a bottom-up market. So it started with pedelecs, even here in Europe. Then it was mopeds, and the next market segment to go is that 110cc market segment. The holy grail in terms of swappable batteries, in our opinion, and we've been tracking them for years, we have similar investors, is Gogoro. Gogoro is based in Taipei. That's the scooter capital of this world. And with Panasonic, they've created these cartridge-style swappable batteries. And what they do is now they sell the scooter, and it's lower performance. So we need to work with Gogoro, and I think Hero already is. We need to work on creating a slightly bigger version for India. But the point is that in Taipei, you can buy a scooter without a battery for less money than the petrol equivalent. You can lease a battery, including charging, per month for less than what you spend on fuel. And the missing link everywhere else in the world is the docking stations. In Taipei, they've put a docking station pretty much on every street corner. You ride, you stop, you swap, and within 6 seconds, you're back on the road. You don't own the batteries, you don't care where they've been, and they have been designed for recyclability. So in our opinion, this transition to the electrification of everything is going to be much more of a city by city approach. So don't launch a bike across the whole country, because your beautiful country is huge. Go city by city by city. In Taipei, more than 500,000 people have switched to electric voluntarily, are extremely happy, and it's done without subsidies. And that's us. Thank you so much for your attention, and please send us your question or if you want to get in contact with us.
Thank you, Vic, Kabir. Extremely interesting session. I'm glad that, using cricketing terminology, I think both the sessions have been hit for a 6. So thank you, Vic. Thank you, Kabir. Once again, we'll come back to you with questions towards the end of the session. We now have our third presentation for the day, a presentation by Mitchell Marks, Business Development Manager at HOTTINGER, BRÜEL, and KJÆR. Mitchell, you good to go?
I'm good to go if you can see me and hear me.
Yes, clearly, can hear you as well. So we can begin. You've got about 15 minutes.
Excellent. Let me start presenting and go from there. All clear? Can you see the slide?
Can see it, yes.
Excellent. Well, thank you everybody for having me today. I really enjoyed the 2 presentations previous, and I think this will be a nice continuation of the work that they've presented from a little different angle. We've heard about some motors and motor controllers, and both of these groups mentioned needing to test their motors, test their controllers, and HBK, HOTTINGER, BRÜEL, and KJÆR, as everybody struggles through, it's a Danish name, offers tools for testing the efficiency of the motors, testing the motor controller, and looking at things like those thermal loadings and failure conditions. So I hope you enjoy this a little different than the previous sessions. Anybody who was here yesterday would have seen a presentation from my colleague in our software department, and he would have shared this slide, and I very much enjoy this slide because as we've learned already, the electric powertrain is really a transmission of DC energy into AC energy through an inverter, into mechanical energy through the machine, and then finally to kinetic energy through some sort of gearbox transmission or chain in the case of 2-wheelers. And we see that compact in this form factor. The smaller we can make things, the more efficient we can make things, the further we can go. And yesterday, if you were at that session, you would have seen my colleague present on some data analyses, where through your testing, you get a wide variety of data for the different reasons. You have to perform calculations to determine the power output, reactive power output, and understand how that whole system interacts, how the inverter, motor, controller all interact with one another. And eventually your engineers will get some plots, and these efficiency plots or flux plots will help us determine how to operate that machine. Now, I think the prevailing question I have from a session like yesterday is, where does that data come from? And what is the quality of that data? So when you go to understand, analyze, design, validate your machine, or in the case of the machine we just heard about overheating, determining what the failure mode was, you need to have some data and high quality data to analyze. So that's what I'll be speaking about. Now, when you have a powertrain, instrumentation does not seem that difficult, but when you start looking at the variety of different sources and the variety of different types of outputs, it can become quite burdensome. So this is a little animated picture of what might need to be tested, and here is the the product that's going to go into our two-wheeler. We have the battery, the inverter, and the electric machine, and through that we're going to be testing the DC energy coming out of the battery. We're going to be testing typically the three-phase energy coming out of the inverter. And this is a high frequency AC energy, so you need a pretty sufficient sample rate. And they're going to be looking at torque and speed coming out of the motor. And what HBK offers is a method to measure all of these into one location. But in addition to these electrical and then mechanical signals, there's also elements of potentially noise and vibration. You don't want the machine to fall off the engine mounts or to make a very unappealing noise. There's measuring CAN bus and digital buses on the vehicle to look at what the machine is thinking, so that you can avoid maybe those over temperatures or avoid some of these states that could result in failure. So instrumentation is a really important part to the measurement process. And HBK offers a solution where we can bring everything into one location. In the measurement world, we do things a little differently here at HBK. So I'll just kind of elaborate on some of the things we do particularly well, and then we'll get into some examples of measurement. So we offer this simple data collection of electro and mechanical signals. So as we mentioned previously, we have this chemical energy in a battery getting transferred to torque and speed. And because of that inverter, because of that motor controller, we really want to understand all the intermediary states as well. So with our data acquisition system, you're able to look at that high frequency inverter, the battery, torque, speed, and then temperature, mechanical signals, all in one place. This is going to simplify your test setup, so you don't have 100 different boxes, so your engineers aren't trying to time align measurements. We make very fast and accurate power measurements, and therefore efficiency measurements. We use some unique technologies that allow us to test very quickly. I'll touch on that a little bit and then show some interesting examples. And then we also have industry-leading accuracy. And accuracy becomes very important because if you're making a measurement, every measurement has an uncertainty. And if your system is 94% efficient and your uncertainty is 2%, well, your actual efficiency could be anywhere from 96% to 92%. And if your engineers are trying to make changes, and let's say they're trying to get this 94 to 95%, you won't even see what that change is if your system is not accurate enough. So accuracy is actually very important when you're making these small, subtle changes to improve efficiency and improve range. Our testing is future-proof. We have a card-based chassis, where if today you have a three-phase motor, you can have one card, but tomorrow you want to look at two motors, or you want to look at a six-phase motor, you want to look at something unique, you can simply add cards. Or if you want to look at temperatures, you can add a card. If you want to look at vibrations, you can add a card to expand as your testing needs it, so you can understand that full electromechanical system. We offer auditable testing, this meaning that we store all the data. So if you're running tests, we can store absolutely every data point that went into a power measurement, store all the data points that went into an efficiency measurement. And this allows you to go to a post-process tool and really analyze what happened, what went wrong, what went right, and develop your machine more quickly and more cost effectively. And we also make all of our equations viewable to the user. This is power, electrical energy are inherently calculated values. And if you're getting values you don't trust, having equations, having data allows you to understand that and again, accelerate that development process. And lastly, we offer feedback to control systems. This is more for the people who are integrating test stands. HBK as a company offers acquisition, sensors, torque sensors, current sensors, speed sensors, and then software to control and analyze all of this as well. All right, what's the good stuff? So what do I mean by auditable testing? So when I say that all the data is stored, and this is very relevant because of my colleague's presentation yesterday on analyzing data, when we're taking these measurements, we can store all of the signals at 2 megasamples per second per channel. This is a lot of data, but this is really what you need to understand those inverters that are switching at 5, 10, maybe even 20 kilohertz in some instances. You need to be able to see those very fast transitions so that you can understand what's happening and understand how to improve that range or how to avoid those failure modes. We show you exactly how we're making all our calculations and we're plugging that data in. This allows you to correlate your test models, allows you to troubleshoot anything that's going wrong, and it can cut down a lot of post-process time by doing some of the work in advance. One of the features that allows us to test quickly, and as we'll see in my example in a moment, this will be really relevant for the two-wheeler market. We're calculating our power on a half-cycle basis. What this really means is if this is the sine wave coming out of my inverter, this red wave, we have digital algorithms running in an onboard computer, in a digital signal processor, where we're identifying zero crossings. We take these zero crossings and we identify the time basis for our calculation. If you dig through the math of electric power, you need to do a measurement every half cycle. And if you have that cycle time wrong, your measurement will be incorrect. So every half cycle, we give you a power value. This allows us to test as fast as your machine. You can actually test while the machine is spinning. And then you can start averaging these half cycles together to get extremely accurate measurements. But what this half cycle measurement allows us to do is as soon as your machine is fixed on a speed for test, you can take a measurement. Boom, next measurement point, boom, next measurement point. It allows you to test extremely quickly and develop that machine more quickly. Also, if you start running things like in-vehicle testing or ramp testing or looking at failure modes during transients, like the scooter startup with the heavy loading, you can understand how the power flow is happening there. So really powerful stuff. And where the rubber hits the road with cycle detect is in something like an efficiency test. And on the right-hand side, I have an example of an efficiency test where I believe the customer had a fixed torque and then they were stepping down speed. So you can see my torque in pink is pretty static. And then I step speed, I get a little spike in torque, it evens out, step speed, get a little spike in torque. And you'll note that on this graph, I have 5 seconds for division. And we can see my voltage and current decreasing. We can see my powers decreasing. And about every second, we're taking a measurement. We're testing as fast as the dyno will change speeds. And this allows us to spend more time testing and less time with the machine heating up, therefore less time with it cooling down. This is an actual real value when you look at time to market and the fact that developing these motors and motor controllers is time consuming. And you can really accelerate your testing. And then because we're requiring all that data, this is all data that's available for analyses, we can bring that to something like the Prensia post-process product and do a very fast, accurate efficiency map, really look at the details of that motor. So really, really cool stuff from the development point of view. Test extremely quickly, sometimes as fast as 10 times more quickly. The electromechanical testing simplifies a single test for many needs. And what this means is that whatever process you're running, you have this inherently electrical to mechanical system. And whether it's your gearbox, whether it's your chain, whether it's your machine itself, there's going to be issues, be it vibration, be it thermal. And by bringing all those data into one place, you can do something like analyze voltage, current, and then torque ripple. And torque ripple, I'm sure some of you had quite a bit of fun with when it comes to chain-driven systems, because you'll physically feel that at the wheel, or you'll squeak the tires, or you'll have a negative experience or possible failures. So you can bring voltage, current, and torque, or possibly if you don't have access to torque, voltage, current, acceleration, or microphone, to understand the full electromechanical system. And by having all these values in one data file, in one test, you can really streamline validations and look at your efficiency, look at sound and vibration, look at control and calibration with one test. You're going to simplify your amount of equipment. You're going to save money on only having one box. And you're going to make a lot of data available for a lot of groups. And this is really powerful, again, in shortening development times, in saving actual capital cost in testing. All right, so now an example, and I'll move through this kind of quickly, but I think this is a very exciting one for the two-wheeler market. I'm located in the US, if you can't tell by my accent, and two-wheelers are not as popular here. We like things that are cars the size of houses. But what we do have a significant amount of is electrical scooters for more of the pleasure market. And I've worked with a few companies now on these. And I think the problems are somewhat similar, not albeit the same. My Indian colleagues have much more experience with the two-wheeler market you guys face. But I think this will be interesting. So we take scooter and instrument it. And a lot of the testing we do with the scooter companies is reverse engineering or benchmarking. So we will actually instrument the scooter on the vehicle to take some of these measurements. And we have a little track that we've done this with. While our system typically lives in the lab, it can also be battery powered to go mobile and do some of these mobile evaluations. So you can sync up your in-vehicle data with your test bench data. So in this particular scooter, we're measuring voltages. So I have my three-phase voltages, my three-phase currents, and we're looking at power dynamically. And this is what the cycle detect allows us to do. We can actually look at that power, reactive power, apparent power, as we're speeding up, as we're slowing down, start, stops. We can catch regeneration. And all of these things, especially regeneration, allow us to extend that battery life. So if we look at actually how the vehicle operates, and we look at these powers in the dynamic setting, and how we navigate overshoots or how we handle slowdowns, we can learn an absolute ton about how to extend the range of that vehicle and the lifetime of that vehicle. So we're going to dig into a couple specifics from this.
Which you have a couple of minutes.
Oh, I got 2 slides left. Sorry for running late. So with that cycle detect, we're able to look at the speed up of the motor, and we're tracking that current as we're increasing, and we can follow that power as a scope trace, and we can characterize these real world scenarios. This applies also for the regen, where we can look at that raw data as the machine's slowing down and understand how we're flowing power back to the battery. And again, understand how to increase the range by doing this, understand what might be failing in my inverter. And lastly, if a wheel becomes airborne, which I'm sure is a problem for everybody in this market, you can look at how your motor controller understands when you become airborne, how you handle that transition, and then how you recover from that transition. So you can really look at the details of how that machine performs. With that, I apologize for going a little over. Thank you for the reminder. Anybody who wants to speak with me further can reach out to me on LinkedIn. Just please scan this code. Thank you for your time.
Which you actually bang on time, so that's quite excellent. And
all right.
For another interesting and heavy session, if I may add.
Sorry.
So thank you once again, Michel, for a good session. And we're now down to our final session for this afternoon, for this particular slot that we have. And after this, we will have a Q&A session. So I'd like to invite Mr. Girish Kamala, Senior Director and Country Head Sales, Automotive at Infineon Technologies India. He will also be running a poll. So for all those viewing, to participate in the poll, please go to the Q&A panel, register your name, accept the terms and conditions, and then you can take part. So thank you, Mr. Kamala, for your presentation, and we look forward to hearing from you. Over to you.
Thank you, Atul. Thank you for the invite. Do you want to wait for a couple of minutes for them to complete the poll, or should we just go ahead and get started, and you can compile it at the end of the session, and then we can see how different things are, because a lot of questions in the poll are what we will cover through these slides.
Absolutely. So shall we finish your session? By then, I'm assuming they would have all registered and then do the poll at the end?
Or you can, or they can do the poll in the meantime. Can they do that concurrently? Do I have to stop presenting?
We can do the poll now.
Okay.
Avinash, can we start the poll, please?
Atul, just give me the cue and then I will start, yeah?
Yep.
Yeah. Are you good to go with the poll?
Yes.
Right. We can start, Girish.
Okay, so I start the slides then?
No.
No, I think, 1 second, let me just confirm.
Yeah, sure.
Vivek, can you give us an update on the poll, please?
Started the second question.
Let's just give it a few seconds.
Sure, Atul. Because I think we are in between people's lunch, right? Just before lunch, so.
Yeah, a crucial time always.
Yes, it is. It is always. I think it's better it's before lunch than after. It's worse. for both the presenter as well as for the attendees to stay awake.
No, I think the first 3 sessions have been really quite informative, quite excellent. So I think we'll have the attention. They may just park lunch for a while.
Poll is over. We can start with the presentation now.
Okay, thank you, Vivek. Thank you, Atul. So good afternoon, everybody. I am Girish and I represent Infineon Technologies. And today I will go through a little bit on the battery management system. Yes, and I saw the other ones where you guys talked about motor controllers, as well as inverters and motors, as well as the system where you can actually measure them. So let me just talk about a little different topic on the battery portion. So what is the battery management system? In a very top level view, they're basically electronic circuits that monitor and regulate the charging and discharge of batteries. This is a very, very broad form definition of a battery management, and we'll walk through the different aspects of this through the presentation. So just wanted to give you guys, just today, because we hear a lot about this, especially with e-mobility coming in, and everybody is talking about, how are you going to manage these batteries, which is, I think, a pretty critical part. And then we also see, it's probably one of the most expensive devices in, an electric two-wheeler or even a passenger vehicle. Yeah. So who do I represent? I represent Infineon Technologies. We are a global semiconductor manufacturer headquartered in Munich, and we can support almost every aspect of the battery management system, be it starting from energy efficiency, safety, connectivity, or security related to your BMS. We have all the devices, starting with MOSFETs, microcontrollers, cell balancing ICs, Bluetooth, wireless, USB, any of these devices, including memory, that are required for you in order to design your BMS systems, as well as we also have the know-how. We can actually help you with developing your proof of concepts for various BMS solutions. Yeah, so this is something, what are the various considerations? Why are we seeing an impetus into the EV market? One is definitely the environmental reasons, strong political movements to fight climate change. There's also political reasons, right? Every country wants to reduce its dependence on oil, save up its foreign currency reserves. At the same time, very critical also what we're seeing today is developing or having their own energy security plan. And this is where the XEVs or the electric vehicles become pretty critical. And also very important, right, is how do we basically save up the renewable energy? And also you can see, whenever you go fill up your vehicles, you see how expensive it is getting, especially in India. And also, like we saw in the earlier presentations, right, swappable batteries. And what is also driving a lot is the battery cost, where we're seeing these battery costs drop to almost $68 per kilowatt hour by about 2020. Oh, sorry, 2030 actually. 2020 is already gone. Sorry. Then, if we look at in terms of EVs, what we see is by about 2040, 80% of all vehicles would be some kind of battery-powered vehicle. We're going to see a reduction in the number of ICE. This is globally in terms of passenger vehicles. And what we see and why BEV are about 58%. And this is one of the main reasons why BMS or developing BMS over time becomes very critical, because about 58% of these are going to be BEVs. Let's look at, overall composition in an electric vehicle today. And why, and I'm just bringing this in to show you why BMS is very critical, because it is responsible for the functioning of the most expensive part in your electric vehicle. If you look at it, about 70 to 80% of your overall cost is the power electronics and battery. And if you just look at battery, right, 75% of the battery is coming from the battery cells. So you really need technology, you really need hardware to actually manage these cells, because they are the most expensive part of a battery. And there's another 25% which is actually spent on a battery cost for integration, electronics, and software. So if you look at it, it really clearly tells you that why is managing the battery, elongating or expanding the life of the battery, having the battery be most efficient is very critical. And that's when battery management systems come in and play a major role. And if you look at it, where we're seeing the cost of these batteries go from where we are today in 2020, about $180 per kilowatt hour, to about $60 kilowatt hour in 2030, and further reducing over time. So another reason why you would essentially need a BMS or a development and technology of BMS, because you're seeing the cell costs drop, right? And there's also increased competition. So each of the cell manufacturers or the vehicle manufacturers have to look at how do they integrate advanced functionalities like BMS into your vehicles or into the batteries, because you have to differentiate. Today, if you look at various OEMs, they are trying to differentiate one from the other so as to basically, be able to penetrate the market. And this is, I think, very important, is this is one of the advanced functionalities that offers to a system, and that is why it's critical for BMS. So another important reasons, yeah, I won't go very much into detail into this. We see what are the drivers. One is definitely geopolitical, commercial, which is also a big cost, is, these batteries degrade over time. How could you actually recycle them and reuse some of these components into future batteries? Changing in, technology, we're seeing changes in cell chemistries, additional of functional safety into these batteries, and also very important is, connectivity. Other big change, which other colleagues also talked about, is the standardization, if we want to do swappable batteries. And finally, I think definitely these are going to be new disruptors in the market, which are going to change the total scenario that we see today. What's also changing in the overall market? Yeah, if you look at it, mainly 20 plus traditional OEMs have been controlling the market, whether it be the two-wheelers or the passenger vehicles. And you can see in terms of two-wheelers in India, mainly you have 3 or 4 players who control the full market. What are we seeing today? We are seeing a lot of new startups coming in, and the advantages the new startups carry is they don't have to balance between the IC portfolio and the EV portfolio. They kind of, you could say that they don't have that excess baggage that come in, and also the huge investments that have actually gone in to develop the IC portfolio, which they don't carry. And as a result, they are able to provide a lot of differentiators, be it in terms of, driving experience, advanced mobility functions, quality, cost, as well as, they have the ability to work on the range. I'm not trying to say that the traditional OEMs are not, they are still our largest customers, but definitely some of the startups have these advantages, which the traditional OEMs don't. Then let's look at, from a battery, yeah? What is a structure of a electrical vehicle battery? What does it consist of? It consists of, a battery pack, and battery pack is then made up of battery modules, and these battery modules then are made up of battery cells. A very simplified view. And where do we as Infineon, a semiconductor manufacturer, come in? One is here in terms of developing and managing the BMS, and also the balancing ICs for balancing the various cells and the battery modules in your complete battery pack. So now, I've been kind of talking about BMS in a very simple state. Yeah. So let me actually tell you what are the various functionalities that a BMS actually does. There are over 20 plus boards, or you can talk of a passenger vehicle battery pack. And the key functionalities that we see a BMS do, one, it helps protect your battery. We just went through, it's one of the most expensive devices in your EV. Very important to optimize. You're spending a lot of money, so you want optimal performance, long life, and very importantly, it also needs to tell you the battery state, which is basically the state of charge, the state of performance of a battery. So if I deep dive into this, right, this chart actually explains completely what a BMS is and what are the various functionalities. For example, if you look at battery protection, it helps you cover things like inrush current, over/under voltage, and also helps in the thermal management, which one of my earlier speakers adhered to, which is very critical. You don't want one of these batteries catching fire. And we've seen some of these instances happen when they've been testing. And other most importantly is monitoring and balancing them, because you want the optimal performance from your battery. So it's basically be it current or voltage monitoring, important also to monitor temperature. And other things include is state of health. And today what we're also seeing with a lot of the vehicles coming in is the over-the-air updates. And this is also very important, where any software upgrades, any software updates can also be done over the air. And that is why the connectivity elements in a BMS are also very critical. Then most importantly then is on the security, because if we have swappable batteries, or if somebody steals the battery pack, they shouldn't be able to use them in a different vehicle unless the system actually authenticates with certain encryption algorithms. Very importantly, you also need to collect data, so you have memory functionalities in the battery. and then communication as well as voltage regulators or PMICs that are also going to be part of your BMS. So what are the different types of voltage classes for which we are seeing BMS systems being developed? First is a simple one, the 12 volt. It could either be lead acid or lithium ion, and mainly under 2 kilowatt for more car types. The second one, which we see predominantly in India with a lot of the EV applications, are the 48 volt systems. And here we're seeing a lot with E2-wheelers and also with mild hybrid vehicles. And the next one is the high voltage, the 400 to 800 volts. And these are with all the various hybrids as well as BEVs, which are usually categorized beyond 50 kilowatt power. Now, we talked about this, right? But what is really of interest for us in India? I think for us, what we're seeing and what my earlier speakers also adhered to was EVs are going to become the main growth drivers of this 48 volt BMS market. And what we see today is we see a BOM of about €6, which is the semiconductor content. And then we see for a mild hybrid, which is something that we are not seeing a lot of penetration in markets like India, about €12 of BOM. And what are the functionalities? Mainly in E2-wheelers is, for start-stop functionality, regenerative braking, torque boost. And what we also see, and which also some of the earlier speakers adhered to, is a lot of these E2Vs are going to largely replace the ICEs. And just like they talked about what happened in Taiwan with Gogoro, it's probably also looking in the future. And yesterday there was a big news from Ola Electric talking about, being able to book a E2-wheeler by paying about 499 rupees. But what we also see here is the mild hybrids may not be able to withstand because one, cost reasons, and also they probably not be able to meet the CO2 requirements that are going to be as per the legislations coming in the future. So what do we see are the various trends in terms of innovations and drivers, and which are very critical that a BMS system has to be managed. For example, is thermal management, not just on the batteries, but also on the various other peripherals in a vehicle, be it pumps, fans, valves. It's very important to manage that. And also very critical why you need a BMS is to manage the thermal runaway. You don't want overheating, and as a result of which, leading to any kind of a fire or a catastrophic effect because of this. So what are we also seeing as new trends in technologies? What we're seeing is wireless BMS, replacing the traditional wired BMS, and we're seeing some penetration starting off 25 plus, where we expect it to reach close to about 5 million vehicles by 2030. Then the most important ones, again, diagnostics to understand how the batteries work. Then there is also various sensors to detect temperature, pressure in the batteries, and also security. Because for some of the things like business models where you want to have pay-per-use, or to understand what is actually happening with these batteries, you also need some of these advanced technologies that are going to get incorporated into your BMS. So this BMS can be either a standalone in the vehicle, or it could actually be mounted onto your battery. And this is something that we need to, depending on the OEM and the actual application, which would then drive this. My last slide. And what do we get from Infineon? And one, we are able to support you with cell monitoring, balancing ICs, metering, sensing. Also provide you with a robust communication system. We have all the devices that can do that, help with thermal management, keep your batteries and your vehicle secure, and provide a lot of the safety aspects that you would need to incorporate into your battery. And if you have any more questions, please welcome to visit our site or shoot us a note, and we'll definitely help you. We also carry a lot of eval kits, which could be a basis for you for your development on BMS systems. So Thank you.